Hello guys, in this video I will be talking about working with full bridge rectifiers. I hope you all know what the full bridge rectifier is. For those of you who don't know, let me give you a quick intro. Full bridge rectifiers are circuits that convert AC voltages into DC. DC voltages are what you get out of a battery or a cell. The DC voltages have a constant polarity on each terminal. That is, the positive terminal will remain positive always, and the negative terminal will always remain negative. But the AC voltages, the kind of voltages we get from the mains or from transformers, change their polarity continuously over time. That is, let's say you have a transformer or a mains voltage at 50 Hz. Then the two wires carrying the voltage will change their polarity from plus to minus every 20 milliseconds. Now, why do we require a bridge rectifier? We need full bridge rectifiers because most of our electronics require DC voltages. And we draw power from the mains, which is in the form of AC. We need full bridge rectifiers to convert AC voltages to DC. Next, let's see how we can make full bridge rectifiers. We can construct the full bridge rectifiers using diodes, or we can also use readily available full bridge rectifiers in the form of ICs. Let's go through each of them quickly. Well, when to use full bridge rectifiers with diodes and when to use full bridge rectifier ICs. Well, I would say if you are a beginner or if you are testing a project, then I recommend that you use bridge rectifier ICs simply because they are easy to use. Bridge rectifier ICs are available in different shapes and sizes, like you can see these three, and we can use them based on our need. For example, this IC is a breadboard friendly IC. If you are working a project on a breadboard, then you can use this chip because you can easily place and use the 4 terminals provided for easy connections. You can connect the AC voltages from the transformer to these 2 pins, which are marked as small sine waves, and you will get your DC voltage plus and minus marked at these terminals as plus and minus. This IC can only be used for currents up to 1 ampere. If you are constructing a project on a perf board, you can use any of these ICs, but most of the time I use this IC, that is W10. Again, it has 4 terminals, 2 for AC marked by the small sine waves and 2 where you get your DC voltage plus and minus. This IC can provide currents up to 1.5 amperes. Hence, if you have a slightly larger current requirement than 1 ampere, then you can go for these ICs. But if your project requires even more current, you can go for ICs like these, which can deliver currents up to 4 amps. So working with bridge rectifier ICs is quite easy. You can just buy whichever IC you need based on your current requirement and use it in your project. To construct a full bridge rectifier using diodes, by connecting diodes in this way. Let me show you an easy way how you can remember these connections. Let's construct a full bridge rectifier on breadboard. I have 4 diodes here. Let's start connecting them. So this is a transformer. These 2 red wires goes to the mains, that is 230 volts AC, and these are the 2 wires, these 2 blue wires is where we'll get our AC power. To easily remember how you can construct a full bridge rectifier using diodes, one of the main things you have to remember is the polarity on these wires of the transformer. Let me take just one of the wires of the transformer, or we can pick any of these 2 wires. It won't make any difference. Now on this wire, if this were to be a DC source, then one of these wires will always be plus, and the other wire will always be minus. But since we get an AC voltage on these wires, this single wire will be plus for some time, that is 20 milliseconds for a 50 Hz signal, and it will be minus for another 20 milliseconds. So we get two polarities on the same wire. This is the important thing to remember if you want to remember how to construct a full bridge rectifier. That is, a single wire will have both polarities. Now once you understand this, that the wire will have both polarities, then constructing the bridge rectifier is quite easy. Let me just insert this wire into the breadboard. Now we have connected one wire to the breadboard. Now after connecting one wire to the breadboard, just connect a diode. Doesn't matter you connect the anode to the wire or cathode. Just connect it. Connect one end to the transformer and insert that end into the voltage rail. Now connect the second diode in reverse to the first diode to the same terminal. Now you can see the transformer wires is connected to two diodes. What happens now is, when this wire has a positive polarity, this diode will get forward biased and you will get a positive voltage on the upper rail. And in the next cycle, when the voltage on this wire is negative, this diode will be forward biased and will get the negative. Now next what we have to do is just connect this wire anywhere else on the breadboard and do the similar connection with two more diodes. Let me do that quickly. So this is it. We have completed a full bridge rectifier circuit. Now I have used this 1N4007 diodes. This diode should be used for currents up to 1 amp. Now you can see this transformer can provide maximum current of 1 amp. Hence you can use these diodes because they are rated for 1 amp. But if your project requires more current and your transformer is able to provide more current, then you can use thicker diodes to make a full bridge rectifier, like this diode 1N5822, which can be used for the currents up to 3 amps. If you are constructing a full bridge rectifier out of diodes, or you are using a full bridge rectifier IC, make sure you read the datasheet for what is the maximum current it can provide, what is its reverse blocking voltage, and what is the maximum DC voltage for which you can use these rectifiers. So this is the full bridge rectifier. Of course, we are missing one thing that should always be used with a full bridge rectifier, that is a smoothing capacitor. DC voltage that we get out of a full bridge rectifier is not pure DC. To convert it to pure DC, we need a filter capacitor of a suitable value. The positive of the capacitor should connect to the positive rail and the negative of the capacitor should go to the negative rail. What value of smoothing capacitor can be used? Easily remember, you can use a thumb rule of a 100 microfarad capacitor for 100 milliamps of current. So if you are constructing a full bridge rectifier of 1 ampere, you should connect at least 1000 microfarad capacitor. Of course, it also depends on the load. For example, if you are using a 1 amp transformer, but if your load is only using 200 milliamp of current, that is 0.2 amp, then a 220 microfarad capacitor will be sufficient. But if your load can take up to 1 ampere of current, the maximum the transformer is supplying, then you have to use a 1000 microfarad capacitor. And most of the time, if you don't know how much current your load is taking, you can take the maximum current that your transformer can supply and choose the value of capacitor accordingly, because the value of current will never exceed the maximum value of current that your transformer can supply. So for a 1 amp transformer, 1000 microfarad will always be good. Of course, you can put a slightly higher value. Instead of 1000, you can also put a 1500 microfarad or 2200 microfarad capacitor. But never put a lower value, because whatever the electronics you are connecting will not perform the way it is supposed to. For example, if you're using a DC motor and you use a lower value capacitor, your DC motor may run slowly. Or if you have an electronic load, let's say you have an LEDs that require 1 ampere of current, and if you put a lower value capacitor, LEDs may shine a little dimmer. So now a full bridge rectifier is complete. I hope you like this, and if you do, please subscribe to the channel. Thank you, and let us meet in another video.